Hi, welcome to Chapter 4. Now, this is part of Module 3. It's just the second half of Module 3. And in this chapter, we're going to talk about the basics of how to write queries. So let's jump in and talk a little bit about that. So, what is a query? It's a question that you can ask your DBMS or database management system, and it can understand it. In fact, we're going to be using Oracle, and we're going to be using the language pSQL, which is how we will write our queries. So how do you implement this in SQL? Well, at least in this chapter, we're going to start all of our queries out with select. Now, don't get me wrong. In future chapters, we're going to use some other keywords to start out our queries, but for today, we're going to use the SQL command select. So, are there any special formatting rules? Not really, but it's interesting is what you'll find is if this is where you go with your career, most organizations, when you get hired on, will have coding standards. They'll have a way that they like their queries to be formed and saved. It allows everyone in the organization to stick to a certain formatting. In fact, in this course, you're going to see me switch between different formats. Sometimes I'm going to use all caps, sometimes I won't. Sometimes I'll have lines broken out, tabbing. Sometimes, actually, in the interest of getting everything on one screen, I may have to shrink the query a little bit by removing some line breaks. So you're going to get a little bit of a view of the different styles out there. And again, there's no real actual rule, so styling can really become something that you're used to until you get into an organization where they start telling you what kind of style that is part of the organization's best practices. So our queries are going to use a select from where statement. You're going to select certain columns from a certain table, and where will actually create a filter on those rows. Now remember, the where clause is optional, and we're going to talk about that here in a moment. So when we want to return certain columns and rows, let's talk about columns first. When you want to select, let's say, 3 columns in a table, you need to list them out. So we're going to say select the 3 column names. And in this case, we're about to show you a query where we're going to list out the number, name, and balance of all our customers. Now, because we're doing that and we want all of our customers, we're actually not going to use the where clause. The where clause is meant to limit our rows coming back. So again, we don't want to do that. We want all the rows, so we're not going to have a where clause. Now this screen is a little bit small to see, but I want to take a moment to kind of go over it. And there's a lot going on here. Let me grab my pen here and talk about things. So first things first is that's the select statement we've been talking about. And with the select statement, we are telling our query that we want to return rows of data. Next up are the columns. And as you can see, there's 3 columns there. And it correlates to what our data is that get returned. Next up, we have to specify from what table. So all of this data is coming from that table. Now, with that being said, you can see we don't have a where clause here. And because of that, all of this data is what's in that table. All the data that's in that table came back to us. Now, real quick before we get off the screen, let me also explain that while this is a little bit of an older version of Oracle's Application Express, or Apex, our version is going to look a little different, but pretty similar. So real quick, here's this tool header. This is where we can change from different tools within the application. We're going to do that throughout the semester. This is where we write our queries, and then this is where all the data gets returned. One thing to note is there are actually several tabs there, and we're going to use the different tabs throughout the semester as well. For right now, we're most worried about the results tab because, again, that returns our data. All right, next up. So one of the things we were talking about is how do we limit our columns and rows? So let's talk about the columns first. If you want to get all the columns back of a table, then you're going to use the select star. And it looks very similar to this. You're going to actually say select star. That says, please return all of the columns in this table. I take a moment to give you a little bit of insight on this. And that is right now, because we're learning the SQL language, we are going to use select stars. At some point, you'll stop using select stars. In fact, most organizations frown upon using select stars. I've seen some organizations, it's downright something you could get written up for, because typically select star can be a dangerous statement. You're asking the DBMS to give you back all the columns, and oftentimes you don't even really know how many columns are in a table. So one of the companies I worked for in the past, we had databases that had 400 or 500 columns in the database with millions of rows of data. And so if you did a select star, you would quickly cause your SQL database to become overwhelmed. It usually throttles out all of the server CPU. Bad things happen, especially on production servers. So oftentimes you'll hear that when you get to organizations that select star is just forbidden. Most of the time you don't want all that data anyways. So most of the time you're going to limit the columns coming back. But for now, remember, select star does bring all the columns back. When you do this, it will list out the columns in order used when the table is created. So basically, if you're creating a table and you create the first column as the ID, and then the second column is the first name, and the third column, is the last name. When you do a select star, more than likely it's going to come back in those order. What I always tell people though is you can't guarantee that. And so therefore, it's another reason why select star is just not a good idea. You're going to want to put how you want your columns to come out. And that's kind of the third thing, is if you want it in a specific order, you need to use the actual names in your select statement. So it's just one of those things that, we need to know what a select star looks like. We need to be able to utilize it. But oftentimes, at some point, we just really won't utilize it. Let's go on to the next slide. And it seems like the computer wants to go a little slow today. All right. It's really struggling, isn't it? All right. I think it's finally caught up with us. So here we go. This is an example, and this is a select star from the items. This is essentially, because there's not a where clause, says give me every column and every row from the items table. And that's what has happened. All right, so now we're on the where clause. The where clause is used to filter down the data. In fact, in this example, we're going to use the where clause to get the row of data where the customer number is 126. It's a simple condition. It's going to have the column name along with a comparison operator followed by the column name or value. That's what that looked like. So here we go. Now this screen is obviously a lot better. It's a little bit bigger. But there's a couple things to point out here. So real quick, we've got select customer name, which we can see right here is our column. But we are doing it and we're saying, show us the customer number 126. But I want you also to notice that's not in our select statement. It's not showing up here. So yes, you can. You can use a column in your where statement and not have it print out, not have it selected. In fact, oftentimes when you're looking at your homework and you're doing what's asked of you, follow the requirements of the question. So an example is if one of the questions says, "Hey, tell us what the customer's name is for customer number 126." Don't give me the ID as well. Don't put the customer number in there because that's not what the requirements ask for. And believe it or not, oftentimes giving more information than the requirements is just as bad as not giving enough. So make sure that you're following those requirements. And in this case, we don't need that customer number as part of the select. I learned my lesson last time. It's better to use the mouse on this next part. So what kind of clauses can we use in our where clause? Well, we have the equal to. These are very typical comparison operators. We have greater than, less than, as well as we have less than or equal to, and greater than or equal to, which what I want to make sure I point out is these are exclusive operators, as in they exclude the value you've given, and these are inclusive operator, as in they're going to include the value you have given. So if you want something that ranges from 1 to 5, when you're doing your where clause, you want to say greater than or equal to 1, so that way it gets 1 as well. And then you're going to do some more operator stuff, and we'll talk about that here shortly. But you also want to say less than or equal to 5, so that way you get the 5 as part of your query. If you don't, if you simply say, let's erase that. If you simply say greater than 1 and less than 5, you will not get 1 and 5 as part of your results back. Be really careful with that. I tend to find that students have a little bit of trouble with that. So just keep that in mind. You want to use the equal to as well if it's inclusive. Otherwise, use it without it for exclusive. So let's take a look at an example. Here we're saying, okay, I want this column, and this column, where, from the customer table, which that's what's going on, where the balance is greater than credit limit. Understand if the balance was 5,000 and the credit limit was 5,000, this operator would not select that row. If you wanted to select that, you would have to do the greater than or equals to operator. Also, balance is both in the where clause, so is credit limit as part of the select. So again, in this case, you can make it part of your select. It's up to you. You don't have to have what's in your where clause as part of your select. Now we can use compounding conditions as well. And that's kind of what we were doing just a moment ago when we were saying 1 through 5, right? We can use the and, or, and the not operators. An and is going to say that all the conditions must equal out to true. And the or is any of the conditions have to be true. With the not operator says it's the reverse of the truth of the original condition. So if it comes back as true, the not operator will automatically make it false. If it comes back as false, the not operator will make it true. Now it's important to understand ands and ors can be a little tricky when you're developing them. I see that students tend to have less trouble with it now that we've become a much more computerized, using computers all the time. We tend to use Excel. We're doing all these things. So and ors have actually become quite demystified over time. But just be careful. Remember, oftentimes when we're talking in English, we will often say the word and when we actually mean or. But we understand the process and we correct the statement in our heads. Whereas if you're finding that you're not getting enough records, more than likely your compound condition is using the wrong and or. So here we have an example. We have where we're selecting one column called description from the item table, where storehouse equals 3 and on hand is greater than 25. A couple of things to point out right away. This is an exclusive operator. So nothing, if on hand actually equals 25, it will not be in our query because we've used an exclusive operator. And in this case, both storehouse equals 3 and on hand is greater than 25 have to be true for that row to be returned. And simply enough, neither of these are in the select statement. So they're not showing up down here. All right. So in this case, we're seeing the difference between an and an or. So keep that in your head. This is saying, hey, give me everyone that is the storehouse equals 3 or on hand is greater than 25, which is funny because they don't really correlate. So this query is an odd query. Not that we couldn't have something like this, but sometimes that happens where right away you're going, well, what does storehouse and on hand have to do with each other? Why would you want an or statement? Well, in this case, they're wanting to demonstrate it, and so therefore, we're going to have storehouses that have, or where the storehouse equals 3, but also anything that's above 25 on hand. Trust me, sometimes you'll get customer requirements that will make you create very odd queries like that. It just happens. Now we're using the not. So what this essentially is the opposite. If we had not put the not in there, then we wouldn't have to worry about the store. I mean, so what it's saying is it's going and it's looking at the storehouse equals 3, and then it's saying, okay, now we're going to do the opposite. So basically, we're saying storehouse is don't return any of the rows that the storehouse equals 3. Return all the other rows instead. Oh, I used a wrong pin here. So let me see. I guess I don't know. I did. Interesting. All right. Hopefully it goes away. Okay, there we go. Oh, I guess we can just draw right on the slides. See, learn something new every day. I've been using my pen tool here. All right, using the between operator. This is a pretty powerful keyword. I use it a lot. It does make things a lot easier. And so instead of using the and keyword, we can, one of the things we were talking about before is we were doing kind of that 1 to 5, right? Where'd it go? It's trying. There we go. It's trying to catch up with me. And we said, we were doing kind of the greater than 1, less than 5. Well, between allows us to do that as well. So we can say 1 between 5.
Playing from MLT100287.
All right. Sorry about that. I'm not sure what happened all in that, but I do know that at some point my Echo device decided to talk. Hopefully we got everything what we needed to on this. But again, the big piece here on this is that instead of using the and operator, we can use the between operator. The other real big thing I wanted to make sure I pointed out is it is an inclusive piece. So it is very much like putting the equal sign under that. It will include the numbers that we've specified. Let's take a real quick example of that. So in this query, please remember that we're taking and we're finding the customer number, the customer name, and the balance, all from the customer's table. And on this one, we're saying between 2,000 and 5,000, the balance. So as long as the balance fits between 2,000 and 5,000 inclusively, it's going to show that row of data. Using computed columns. So in this, we can utilize and put together data. We can do arithmetic. We can return data that doesn't exist in the database by using computed columns. And really the easiest way to get into that is to kind of just take a look at that. So in this case, as you can see here, we're returning this customer number, this customer name, but then we're taking two columns that are in our table, we're subtracting them and returning that as its own column. Now in this case, we haven't named this column, so it's just going to come back with this kind of weird name, attached to it. But this is us doing some arithmetic. It's also an important thing is oftentimes when we talk about tables and data and databases, anything that we can do computed, we should. We shouldn't store that data, typically. There are some reasons, and maybe at some point throughout the chapters we'll talk about that. But again, for most data, most normal-sized databases, whatever that means, we don't want to store data that we can calculate. It's just a waste of space. So, for example, if you have, let's say, an order line column where you're going to put how many of a particular item someone's ordering and what that base price is, we don't need to put another column that is the total price because we can always just multiply the quantity by the amount to get that field. So why store that? Why waste that time? Like I said, there are some times, but for the most part, you don't want to do that. So this is what's going on with this particular query. We can see where we're doing some arithmetic and returning it as a column. All right, now this is where it's really cool is we're going to take that same piece. So here we are again, but this time by using the as keyword, we're going to name it. So that's why this available credit is the name of this column, because the as available credit is how we named it. Again, that might be something when you get into an organization, maybe a part of their best practices. In fact, the company I work for right now during the day, they do have that as a pattern that everything has to be named specifically. We don't let the database come up with its own name for that column. The like operator is a pretty powerful operator. It's meant for searching alphanumeric kind of fields, or varchar, nvarchar, that kind of stuff. And the percent signs are wildcards. So what we need to understand here is this being out front and out back means that as long as this word Columbus fits somewhere in the middle, including on the ends, because again, this wildcard could mean no character as well, it will return that piece of data. So here, what we're talking about is 123 Columbus always will fit that wildcard. This percentage, because there's nothing on the end, fits as well, because the percent can also, as a wildcard, mean nothing. Same thing on this one, but just the opposite. This percent matches no letters out there, and this matches all of these letters. So if we had something similar and we had 1, 2, 3 Columbus, IA, this would still match because this would represent all that, and this would represent those pieces. Additionally, when we're using the like keyword, we can use an underscore. That represents just a single character. This can represent 0 to many characters. This represents one character. So this obviously fits this, or this, but would not fit that. So here's an example of that like query. I'm not going to spend too much time on this screen because it's pretty evident of what we just literally talked about. And one of the things I will say is, as you can see here, because it's got it on both sides, it's going to match both sides. Now, you don't have to use it on both sides. You can literally say, whoop, I'm using the wrong pen again. I guess I can switch over to my right pen so that way you could say, whoop, and then there is no wild character here, so it would have to be at the front, where the wild character out here allows 0 to as many characters as you want, as long as it matches. You don't have to have it out both front. The good old in operator. So the in operator just allows you to have series. As you can see, we have a series. So, but it has to match the series specifically. So it would be, is it in 5,000? Does it have 10,000 or 15,000? Not in between, like we did before with the between. It would have to be, it's only going to return the rows that match that 5,000, that 10,000, or that 15,000 directly. Another big piece of querying is the fact that we need to be able to do sorting. To sort, because remember, we told you, you can't guarantee how the data is going to be returned to you. Rows could be out of order. There's no real such thing as an order in the back end of a database. So to make sure you get the order that you want, or the sorting, we're going to use the order by clause. Let's see if we can take a look at some of the example. When we're using the order by, we're going to have a sort key, which is a column on which the data is to be sorted. Ascending is the default. Please remember that. That typically is a test item. Ascending is default. If you want it to be otherwise, you'll have to specify that. You can have a major sort key and a minor sort key. We're going to see examples of that here in a moment. And remember how we were just saying sorting is always defaulted to ascending? You can use descending to say, hey, I don't want it ascending. I want it descending. So what does that look like? I just made a dot. Here you go. Again, the select statements are all there. We've got 3 columns. We're bringing it back from the customer table. Now, interesting enough, there's no where clause here, so it's returning all the rows from the customer table. But we are putting it in order, and we're putting it in credit limit descending. So first, it's going to do this, and it's descending. That's the major key. And then customer name, because it's after that comma, is the second sort order, or also known as the minor sort order. And because it doesn't say descending, that means it's automatically ascending. But remember, it has to do it first here, and then it's going to do, that's why A and then K. And then 10,000, you're going to see B and C again. So it's going to restart because the major key comes first and then the minor key. We also have the ability, so we've already talked about some arithmetic. We can also do aggregated functions. We can say, give us the average or a count, a max, min, and a sum for our data. It's pretty self-explanatory. Average is going to calculate the averages of a column. Count is going to tell you how many rows are in that, come back from that query. Max will tell you what the maximum value is in the group data. Min will tell you what the minimum value is in the group data, while sum takes sort of like the average, but instead it just does the sum. It gives you back the addition of that column. So what does that look like? All right, so here's an example of us using the count function. In this example, we're saying select count star, and we can use the star to represent any column. If we were writing this query and we wanted to represent that we're counting a very specific column, we could also put that instead of the star. But most people, oftentimes, when they're doing the select statement, they just put count star in this case. So in this case, it's saying count the rows where the category equals GME and tell me what that count is. And here you can see that's exactly what's happening. It's telling you what the count is. So 6 rows from the items table match this where statement. When we use the sum function, we're going to calculate the totals of a column. And the column must be specified and must be numeric. Null values are ignored. So this is kind of an example of some different ways we can use the average, max, and min functions. Here we're saying, give me all the sums of the balances, give me the average of the balances, give me the max of the balances, and then the min of the balances. For all the rows, because we don't have a where statement in here, we have no where statement, so it's just from the customer's table. So this is the total sum from the customer's table, that average of their balance, the max value of the balance, and then the min value. Using the distinct operator. When we gather data back from a table, there might be duplicate rows. Maybe we ask for all the first name and last name of our customer. Or let's just go even more simple. We ask for all the first names from our customers table. Maybe we want to order name tags and send it to all of our customers, right? We could say, hey, I want to just make a distinct list of all the people's first names. So there could be a bunch of Johns in my customer table, but I only want John to come back once. So using distinct allows me to say only repeat unique information. Only give me back unique information. Don't repeat anything. So customer 126 and 586 each have 2 orders on file. Okay, so we can see that because we have there's 126 twice and 586 twice, and you can see that these rows are repeated. So if I go to the next slide, and we do it with the arrow instead of the dot, excuse me. Because we're using this distinct function now, it doesn't return 126, and I think it was 586 was the other number, twice. It only returns it once. That's how distinct works. You'll believe it or not, you'll use distinct quite a bit. We can also nest queries. Well, what does that mean? When we nest queries, we're going to have two queries. One's going to be within the other. It's also known as a subquery. The inner query placed inside of another query is always known as the subquery. The outer query uses the subquery results. Please keep that in mind. Queries go from the inside out. So if you've got nested queries, if you've got query 1 that then uses, it's off of query 2, and we'll see this in an example here in a moment, that also then has query 3 nested. Query 3 first runs, returns that to query 2. And query 2 runs on that data that was returned from query 3, and then returns that data back to query 1. So query 1 only queries on the rows returned back from query 2. Let's see if we can see that as an example. So there you go. In this, we're saying select order number from order line where item number in, and then this is our subquery, select item num from item where category equals PZL. So again, what's going to happen here, this query runs first. The data that it comes back with is then passed to the outer query, and this is ran on that data. And then whatever's left over is returned to the screen. So here's another example. Again, we're just nesting data. It's important to know that what's going to happen is we're going to get the average balance for customers. So what we're saying is, hey, go look at that data in the customer table and find the average balance. What's the average balance for the entire table? And now take that and tell me if there's anyone that has a balance that is higher than that. And not inclusively, by the way, because we didn't use the greater than or equal sign. So let's say that this query right here does the average, and it says, you know what, the average is $2,200. That's the average. What's then going to happen is, so remember, $2,200 is it kind of gets rid of that and then just puts $2,200 there. And then that query gets ran, and that's the data that's returning. All right, we're almost there. Grouping. So grouping just allows us to put together similar pieces of data. Rows of data that share common characteristics. Calculations in the select command are performed for the entire group. So what does that mean? Well, we're going to group data on a particular column, and we're going to calculate statistics. Let's take a look at that. So first, we are going to say select rep, and you're going to see this average balance from customers grouping by the rep. So what happens is it says, okay, we're going to group by this rep number because this rep number is in the customer table multiple times. 15 is in there multiple times. So it's going to say group it by 15 and then give me the average balance for 15, which is that. And then we just happen to add another statement that we're pretty familiar with, which is to tell it to order by rep number. And remember, rep number is ascending, so it's going to start with the smallest number and go up. So kind of make sure you understand that is first, all the data is going to be put together based on grouping. And then it's going to perform this function on that grouped data. If you didn't have this grouping statement, what would happen is you would have the data come back and just get in. First off, it would complain because wouldn't like that. But let's just say we didn't have that column in there and we didn't have the group by in there. It would look at all the rows in the customer and just give you one average for all the balances. But because we have the groups, it's going to do it based on the group information. Now, we've already dealt with the where clause. Having is very similar to the where clause. The difference is having pertains to the grouped data. So where clauses are on singular pieces are on each row, where the having is affects the grouping of data. So what we're saying here in this statement, this average balance is greater than $1,500, is after it groups the data, after it does the average, then only return those averages that are greater than $1,500. So this happens after the grouping. Having versus where. We kind of talked about this. Where does limitations or filtering on rows of data. Having is on groups. It filters the groups of data. So I always tell people, remember, on where it happens during the select process. Having, it happens after the data has been grouped. Then it does the having. So you can use these together, by the way. You can first limit rows that then get grouped together, that then get filtered with the having statement. So here's an example of that. This is where we are telling it to select the credit limit and the count for customers where rep number equals 15. So right away we're saying, get rid of all the data where the rep number isn't 15. If it's not 15, don't even start with it. Don't even do the credit limit and the count. But once you've done that, now group it by that credit limit and tell me the ones, and then tell me how many rows of data you found in that credit limit, and then show me only the rows that are that are less than 2. So I know this is a little bit hard to digest. You might want to take a moment to pause this and kind of take a look at that. But first, we're going to. This is number 1. Man, let me try to redraw that. That's not all that great. So the where is going to be filter number 1, and it's on the rows. And then we're going to then group that data that's returned back from that. And then we're going to only return the groups that are less than 2. So that's an example of how you can have both the where and the having. Nulls. What are nulls? Nulls are it's pieces of information that just doesn't exist, right? Conditions that involve a column that can be null, right? We've already, so let me back up a moment and explain nulls. Nulls are different than, let's say, a blank string. So you can have, let's think of a time. Let me use the right pen here. Right. So a blank string equals where we have quotes. Man, that's sorry. My handwriting's a little bad today. I got a keyboard in front of me. Let me see if I can move the keyboard so I can get a little closer here. So, what I'm saying is, a blank string equals when we put double quotes together and there's no space. Zero space. That is what's known as a blank string. However, a null isn't even that. A null really is absence of data. There's nothing there. In fact, if you were to look way behind things and you get really down in the deep, a null points to a blank space in memory. There's no such thing. So keep in mind, blank strings and nulls are significantly different. And that might drive you crazy at some point. In fact, if you get into this business, it will drive you crazy on more than one occasion. The reason why I bring that up is because we can do where clauses where street equals null. This is going to tell us where there's rows of data where the street column has absolutely no data in it, which is different than saying where street equals bloop, bloop, with no spaces. This search is a legitimate search. It's looking for where the street has a blank string in it. These two are not the same. Don't get them confused. And the reason why I bring all that up is, again, what we just saw where I did the search for the blank string is how you would do that. But oftentimes when you're not dealing with blank string, you're dealing with an actual null. You have to use these commands: is null or is not null. So that's how you do null statements, or you do searches for null statements. So now that kind of brings chapter 4 to an end. I know this video is a little bit long, but the information is pretty straightforward. It's not too complicated, and you'll use these keywords for your homework assignment for this week. So kind of keep that in mind. Hopefully you took a little bit of notes. If not, always go back in the module. You can grab the PowerPoint for this and look through that. If you have any questions, please feel free to shoot me a message. Thanks for hanging out with me and taking a look at Chapter 4. As I try to stop this video.